Hi, welcome to the Indian Society of Toxicology's YouTube channel. We have done a couple of presentations and you may have watched those also. We will be continuing with this series. We thought we'll have two slots, one for undergraduates and interns and the other for faculty and postgraduate students of various streams of medicine. So what today we will be discussing will be very basic and mainly targeted at students, but also I'm sure the postgraduates and faculty also will find it useful. There are so many aspects of general toxicology that we take for granted, but some of these are not really correct or updated. So we'll try and give you what we feel should be taken as authentic. So let's begin with what we refer to as general toxicology or general aspects of medical toxicology. We look at various kinds of definitions and classifications and things like that in this session. We'll begin with the first slide, and that is to do with definition of the subject itself, and that is toxicology. So let us look at aside from that what we will be discussing in this particular section: poison, drug, toxin definitions, laws related to poisons, classification of poisons. There will be others also. So let's look at the most basic definition, and that is definition of toxicology. When we look at this particular word toxicology, various interpretations as to what it means. So there is no such thing as a standard definition. What I will be giving you is a well accepted definition, which I think will give you an idea as to what the subject is all about. So as given here on the slide, toxicology is defined as a science which deals with the knowledge of sources, characteristics and properties of poisons, their symptoms in the body on exposure, and the treatment. You will notice that this definition is mainly medical, because toxicology is not just medical. It can be other aspects also, like environmental or analytical, so many other kinds of toxicology. So it's a very vast field. Indian Society of Toxicology, as you know, is dedicated to medical toxicology. So we will restrict definitions mainly to medical aspects. Therefore, you have to have something that that will focus on all the medical or clinical or forensic aspects that a medical student or doctor is expected to know. When you talk of toxicology, as to how will you define it purely from medical point of view. I've got a mnemonic for you, and that is an acronym. You can read that mnemonic or the abbreviation that I'm giving as a word. You can pronounce it like a word, and each letter in that word stands for something. So when we look at medical toxicology, we say it is a science that deals with a patlet of poisons. Patlet is the acronym or abbreviation, and that stands for the following: P for properties, A for action, T for toxicity, L for lethal dose, E for estimation of poisons, and T for treatment. This is, I think, the best way to define medical toxicology, because you have a mnemonic, you have a memorizing aid, what we call an abbreviation here or acronym. You just remember that patlet and you can just reel it off, the whole thing, in the form of a definition of toxicology or medical toxicology. Now, in medical toxicology, since in India we have toxicology attached to forensic medicine, we emphasize a lot on forensic aspects. In this particular section also we will look at forensic aspects, but please understand that we will not confine ourselves to forensic toxicology. But forensic toxicology, for the sake of definition, application of knowledge of toxicology for legal purposes, as simple as that. We look at various forensic or legal aspects also. Now when we come to another very basic definition, and that is poison. What does it mean? If you ask me to define poison, I may very well ask you a counter question as to what is not a poison. I'm not very sure whether anything exists which is not a poison in this world. This was in fact emphasized, stated actually long ago, several centuries ago, by a Swiss alchemist by name Paracelsus, and he said this very famously: there is no such thing as a non-poison. Every substance is a poison. It all depends on the mode of administration and the dose. So that means even the food that you eat or the water that you drink can be poisonous. Because if you take food excessively, you get ill. That is nothing but toxic effect. Or you drink too much of water, there is water intoxication. So nothing in this world is a non-poison. But of course, from the scientific point of view, that is not a definition that you should be remembering. It is just for the sake of historical purposes I mentioned that. Medically, this is how poison is defined. Again, there is no standard definition. I'm just giving a definition that is easy for you perhaps to recall. Poison is any substance which, when introduced into the living body or brought into contact with any part thereof, will produce ill effects or death by its local or systemic action, or both. Easy, isn't it? You just remember that whatever be the substance, if it is brought into contact with the body or any part of the body, if it has some local effect, some systemic effect, or both, it is a poison. And as I said, to talk of something as a non-poison, it is meaningless, because almost everything in some way is poisonous. All right, there are some common, myths that we need to dispel. Some of these myths are in the form of similar sounding terms. Sometimes we take them to be synonymous. Like for instance, poison and toxin. Many people think that the poison is the same as toxin and vice versa. And to some extent it is true, but it is not entirely correct. So if you want to be precise, then really speaking, there is a very fine though subtle difference. Poison is actually anything that is toxic, whereas a toxin is a poison that is derived from an organic source. So it can be a plant source, it can be an animal source. There are various kinds of toxic plants. There are various venomous creatures which can bite or sting. There are even microorganisms like bacteria which produce toxins. All these are covered by the term toxinology, which is a subspecialty of toxicology. That is, deals with the study of toxins. So toxin, I can say, is definitely a poison, but a poison need not be a toxin. That's the best way of putting it. Then again, there is a bit of a confusion between drug and medicine. Much of the time we refer to drugs as medicines and medicines as drugs. And most of the time this is all right, not much of a difference, but there is a subtle difference again. If you want me to specify as to what that is, I would say that a medicine is a kind of drug. It has therapeutic properties. If it can be used to treat some ailment or affliction or pain or disease, you call that particular substance as a medicine. So a drug need not always be medicinal. We have, for instance, drugs of abuse. So a medicine is definitely a drug, but all drugs are not medicines. So pharmaceutical agents like aspirin, antibiotics, these are all medicines. At the same time, you can also refer to them as drugs if you would like. Today there is a term called Xenobiotic, very important to remember, which covers everything: toxins, poisons, chemicals with deleterious effects on the body. All are covered by a single expression called Xenobiotic, which is given here, the spelling is Xenobiotic. Xenobiotic. Remember that. Xenobiotic is an umbrella term that covers all substances with toxic properties. There are also some important laws related to poisons that you should know. Of course, laws will vary depending on the place. So what laws we have in India may not be applicable to the US and so on. We will touch upon only laws which are applicable to us, that is the Indian subcontinent. So under this, there are some which you should read in detail, not really the forum for going into the details of these laws, and just mentioning them so that you can take a look in detail from authentic sources with regard to these laws. Some of these are very important. Like for instance, there is this Narcotic Drugs and Psychotropic Substances Act, also often abbreviated to NDPS Act, which covers mainly substances of abuse. All the legal problems and the penalties, etc., are covered in this act. Please do go through the details of this act, very important. Then we also have acts like the Drugs Act, passed way back in 1940, has undergone various amendments over a period of time, and that covers mainly, all kinds of pharmaceutical agents and other drugs and all that used for therapeutic purposes. So you can say that, like the Pharmacy Act of 1948, these acts are more relevant to pharmacology than really toxicology. But then pharmacology and toxicology is very closely related, and we know that almost every drug has side effects, adverse effects, then effects on overdose. All these are covered by toxicology. So we need to know also about Drugs Act and Pharmacy Act. With regard to statistics, it's very difficult to be accurate with regard to poisoning because it is such a vast field and it covers so many kinds of situations that to have comprehensive, accurate statistics is very difficult. But I'm giving you some, kind of bird's eye view of statistics, whatever is available from recognized, organizations like World Health Organization or WHO, which says that on an average globally 3 million poisoning cases occur and about 220,000 deaths. With regard to the number of chemicals that can cause serious poisoning, more than 9 million, millions. This is an open-ended list. It is I don't think you can ever close it. Each year, each month, each day, new chemicals may be added. But it's also important to remember that not all of them are encountered in toxicological practice. In fact, only a few thousand, less than 3,000, cause more than 95% of poisoning cases. And that is why, as a toxicologist, you should understand that it is impossible to be some sort of an encyclopedia and know about every poison that exists. Know in detail about those substances which are common to your area. They are inevitably part of this 3,000 list of chemicals. In India, the statistics that we have say that more than 50,000 people die every year from toxic exposure, which I think is a gross understatement. It must be in lakhs, I feel. But we don't have accurate statistics, so we have to look at the figure from definite point of view, and definitely there are more than 50,000 deaths that occur every year. But I should say that it is an understatement, I repeat that. And unfortunately, many of these deaths occur because of lack of specialized care, because toxicology is very neglected in India in the medical curriculum. One of the purposes of starting this channel on toxicology is to address this issue and to focus more attention on medical aspects of toxicology. And I hope through this channel, medical students and doctors will get useful information which will help to improve the status of toxicology. Then there are one or two other favorites in the examinations that are asked, of students. Some of them actually are not very important, but since they are so commonly asked, we have to touch upon them. Students may be asked, is there something like an ideal homicidal poison that can be used to kill somebody? And the characteristics I've listed here. If a poison has got all these characteristics which are listed here, then maybe yes, you can say that it's ideal to use it for murder or homicide. Similarly, a question may be asked, which is a poison that can be considered ideal to commit suicide? And so you have something called ideal suicidal poison with these characteristics listed on this slide. Again, I would say that these are all concepts which are not all that pertinent or relevant, and since they are being asked in the examinations, we are just touching upon them. I'm not giving you any examples because that is fruitless. Somebody may say so and so poison may be ideally homicidal, but somebody else can disprove it. And the so-called ideal homicidal poisons have been used, and people who have perpetrated such crimes have been caught also. So there is no real ideal suicidal or homicidal poison. So I would say that practically speaking, ideal homicidal or suicidal poisons are mostly theoretical and not really practical. They don't really exist in nature. All right, we will look at, before we go to classification, we'll wind up with that, some common terminology in toxicology, because again there is some confusion sometimes, even with medical students and sometimes even faculty. So there are terms like, for instance, fulminant poisoning. What does it mean? As opposed to acute poisoning or subacute poisoning or chronic poisoning. Fulminant poisoning is massive dose that has been taken of a chemical or drug or toxin, whatever, xenobiotic, causes rapid death with collapse. Whereas acute poisoning is where a single large dose has been taken, not really a massive dose, it's all relative. Or it may be several small doses taken in a short period of time. Can also give rise to acute poisoning with abrupt onset, as opposed to chronic poisoning where small doses are taken over a long period of time with insidious onset and insidious manifestations. And finally, you have subacute, which is a mixture of acute and chronic. So don't confuse between these four terms: fulminant, acute, chronic, and subacute. Similar is the case with terminologies like these. For instance, action of poisons. What do you mean by action? Because poisons can act by so many means. And when you say what is action of a poison, you have to be very specific. Poisons can act, for instance, by inducing local effect, exerting effect that is mainly locally, the part they come in contact with. Like, for instance, you have examples like acids, which come under corrosives, which act mainly on the skin or mucosa. They are rarely absorbed systemically, so you don't have much by way of systemic features. Then there are drugs like atropine. You instill in the eye and you get various kinds of manifestations. So these are, xenobiotics with mainly local effects, as opposed to those which have mainly systemic effects. And that may be on one or more than one organ system. Like, for instance, opiates or opioids, which act on the central nervous system mainly, or a drug like digitalis acts on the cardiovascular system, mainly the heart. Or there can be those with combined effect, that is both local and systemic effects. For instance, carbolic acid, also called phenol, which has effects on the skin or mucous membrane locally in the form of corrosion, and also can be absorbed systemically with systemic manifestations. Also the same case with phosphorus. And with regard to medical legal aspects, what we will be touching on in subsequent episodes, we will be looking at accidental, suicidal and homicidal poisoning basically, because these are the three main aspects of medical toxicology. And as promised, we will wind up with the classification of poisons from the medical point of view. And for that, again, I'll give you a mnemonic, and that mnemonic will, I think, help you recall the numerous examples of poisons or xenobiotics that you need to recall in the examination. The mnemonic that I'm giving you, again, is in the form of an abbreviation or an acronym that can be read off as a word. CINCAM, C-I-N-C-A-M, each letter standing for a group of poisons or a major category. The first C, caustics or corrosives, both mean the same. I for irritants, N for neurotoxic poisons, not neurotic. There's no such thing as neurotic poison. Cardiovascular poisons is second C. Then A for asphyxiants and M for miscellaneous. These are the 6 major categories of poisons, what we call classification in medical terms is represented by these 6 groups, each of which of course has subcategories, so you need to remember that also. So let us look at the first group, caustics or corrosives. You have acids, which may be inorganic or mineral, like sulfuric, nitric, hydrochloric. These are the commonest mineral acids. Or it can be organic acids like carbolic acid, salicylic acid, oxalic, and so on and so forth. Then you have alkalis like ammonia, the salts of sodium, potassium, calcium. This is the first major group, that is corrosives or caustics, comprising acids and alkalis. Acids may be inorganic or organic. Coming to the second major category, that is the I in SYNCAN. Irritants. Irritant poisons again may be inorganic, which may be in the form of inorganic elements that are non-metallic in nature, like phosphorus, or halogens like chlorine, bromine, etc., etc. Or it can be metallic irritants, what we call heavy metals, arsenic, lead, mercury, copper, iron, thallium. There are so many, but these are the most important. And then you have the second subcategory, organic toxins, which may be irritant plants, toxins derived from plants like castor, calotropis, croton, abris, commonly seen in India. Or it may be the form bites and stings from venomous creatures, creatures which have venom, like for instance snakes, scorpions, spiders, bees, wasps. All these are what we call toxins derived from animal source and delivered in the form of bites and stings. Coming to the third major category, and it is really a major category because it has got a number of subcategories, and that is neurotoxic poisons, which may be those which act on the brain. We call them cerebral poisons, which may be somniferous, that is sleep inducing or dream inducing, like for instance opium and opiates. Or it can be those which intoxicate somebody, cause kind of disorienting effects, that is inebriants. Alcohols, barbiturates, benzodiazepines, etc. are important examples, and also some pesticides. Then you have those which can cause delirium. We call them deliriant poisons, altered states of consciousness with maybe agitation, delusions, hallucinations, violent behavior, and so on and so forth. Important examples are datura, cannabis, and cocaine, usually included here, but I would say, strictly speaking, not correct, because cannabis is not a classical deliriant. It maybe has inebriant properties also, and cocaine is certainly not, really speaking, a deliriant. It's a stimulant. It's the most powerful stimulant known to man, and maybe it should have been placed in a category of its own. But this is the conventional kind of classification. Then you have mind-altering poisons called psychotropics, which may be antidepressants like amphetamines, tricyclics, and so on. Neuroleptics, also called antipsychotics. The common examples are listed here. And then you have the most important example from forensic point of view, and that is hallucinogens or psychedelics, of which the most important example is of course lysergic acid, diethylamide, or LSD. You also have phencyclidine. Some of these are the domain of pharmacology more than toxicology, but a few of these definitely have a lot of forensic aspect involved. And then the category of neurotoxic poisons that act on the spinal cord, spinal poisons, stimulant in nature, of course everybody will recall, and that is strychnine. But when you ask examples of depressant spinal poisons which produce paralysis, sometimes students don't come up with the answer, and the answer actually is gelsamine, derived from yellow jessamine, a kind of plant that grows in the northeast part of India. Strychnine, we all know, powerful stimulant, produces convulsions. And finally, the last category under neurotoxic poisons is peripherally acting, like hemlock and curare, which also has got varied kinds of manifestations, usually paralytic. Then we come to cardiovascular poisons, the fourth major category, under which you have antihypertensives, anticoagulants, not all that important from the forensic point of view, more from the clinical point of view, yes, and cardiotoxic poisons which have got tremendous forensic importance. Those which act directly on the heart, like aconite, oleander, odollam, digitalis, etc. The fifth major category, asphyxiants or irrespirable gases, toxic inhalants. You can call them, any of these terms, but very compact expression is asphyxiants. So that is how we usually refer to these irrespirable gases in toxicology. The important examples, of course, carbon monoxide, then cyanide gas, that is hydrogen cyanide. You also have the notorious gas that killed thousands in Bhopal, methyl isocyanate, and various kinds of riot control agents called tear gases. And the final group, as I say, last but not the least, because a huge group and some of the most important poisons actually are classified here, comprise the food poisons, which may be poisoning due to microbes or mushrooms or plants or fish or chemicals. You also have a huge category of pharmaceuticals. Not possible to list everything here. Again, main domain is pharmacology, but they do have toxicological ramifications. And then, of course, pesticides. Many pesticides also can be classified here because they need actually a separate kind of category. And substances of abuse. These are the miscellaneous agents. So I repeat again, mnemonic is SYNCAM, 6 major categories of poisons: caustics or corrosives, irritants, neurotoxic poisons, cardiovascular poisons, asphyxiants, and miscellaneous. Don't forget that. You remember that, you will remember much of toxicology, because if you know which category a particular poison belongs, believe me, even if you are not read very well, you will be able to use some logic and find out as to what kind of manifestations it may produce and what kind of management measures you have to undertake in treatment. This is a table that shows you toxicity rating of poisons. This is not really all that satisfactory because there are so many kinds of poisons which may be difficult to fit into one or the other of these categories. A lot of controversy also, but it is a fairly good kind of classification to at least say approximately as to whether a particular chemical is highly toxic, or we need to be very concerned if it is seen in a patient as exposure, or is it something that it's not all that toxic. So maybe you can take a look at this table in detail and find out as to what is meant by super toxic poison, what is meant by a practically non-toxic poison. But again, I emphasize there is no such thing as a completely non-toxic substance. So that is all with regard to part 1 of general toxicology from the Indian Society of Toxicology. We will be continuing this series because so many other aspects of general toxicology that could not be covered here. We don't want this session to be too long. I hope it has not been too long already, but we will look at the other aspects of general toxicology in ensuing sections. So thanks once again to Dr. Somnath Das, who actually prepared this presentation, a basic presentation. He is a professor and head of forensic medicine and toxicology at R.G. Carr Medical College, Kolkata. And he is also the in charge of the new Poison Information Center that he has established there. Thank you very much, Professor Somnath Das, for a wonderful kind of presentation. I just mainly did the voiceover, but the full credit for this presentation goes to him. Thanks also to the team behind the production of this presentation, the current office bearers of the Indian Society of Toxicology, right from Dr. Girish to Dr. Sri Krishnan to Dr. Sabarish and all the others. So we'll meet again in the next episode. Thank you all for watching. Goodbye.